This is my file server. It's basically a normal x86 computer like you have at home, but instead of Windows or Linux, it runs Android, which is technically also Linux, but you get the point. This is cool and I really love the setup I have here, if it wouldn't be for the energy consumption. Right now it's drawing about 70 watts of power while doing absolutely nothing. That doesn't sound like a lot, but here in Germany electricity is pretty expensive. With the current average rate, this thing costs 74 cents per day or 22 euros per month, just for electricity alone. For that amount of money, I could rent a pretty decent server to store my data off-site if I wanted to. But I can't do that because my ISP sucks. I already have the fastest internet connection available in my area, but it's still way too slow for this use case. Since cloud stuff isn't the solution, I have to go with the next best thing, making my own server consume less power. I already managed to decrease it from 100 watts to around 70, but now I'm stuck here and I don't think I can really get it any lower than that. At least with this hardware. And trust me, I've tried. So now that the problem has been established, let me show you what I want to do about it. Since I can't really make the existing server use any less energy, I have to replace it with something else. The core of all this will be an 11th gen framework mainboard. The reason for choosing this board is that it has been designed to be part of a laptop, which makes it very energy efficient. Since Framework has a very open approach to the hardware, I can use it outside of a laptop without any weird behavior. Obviously, I can't just connect a couple of hard drives to this board, mainly because it doesn't have any SATA ports. But lucky for me, there's a perfectly fine PCIe slot right here. I just need to convert it from M2 to actual PCIe and I'm ready to plug in whatever I want. Which in this case means a PCIe SATA controller. To this controller I'll be connecting the hard drives and also a SATA SSD as a cache. Of course, I also want to have some external I/O on my server. For this I have a bunch of USB dongles to connect to the motherboard. This one is for HDMI and this is for 2.5 gigabit Ethernet. And the last one is just a USB 3 hub for the boot drive and some other spare USB stuff. For Ethernet, I also have two panel mount extension cables, so I can neatly integrate them into a custom I/O shield on the back. The reason for only needing Ethernet on the back is that I will be using PiKVM to manage the system remotely. For this I have a Raspberry Pi 4, an HDMI to CSI adapter and a couple of cables to connect it all up. And now, last but not least, there's the power situation. It's probably the most janky part of this whole setup because I couldn't be arsed to come up with something more elegant. I basically have four power supplies. One is for the Framework motherboard. It just plugs into the free USB-C plug and that's that. Then there's a second one for PiKVM. I wanted the whole thing to be as standalone as possible and this way it doesn't rely on the rest of the system working. And the last two power supplies are for the hard drives, the SSDs, the PCIe card and the fans. It's a normal 12-volt power brick and a 90-watt Pico PSU. I didn't think I needed that much power, but that was the lowest one I could get. To hook it up to the HDDs, I just need a SATA power splitter like this. For the PCIe card, I have a Molex to floppy adapter. And for the case fans, I have this Noctua fan controller kit. It comes with a SATA power to 4-pin fan plug and the controller itself, and also a fan splitter for all the fans. The fan controller will then be set to a reasonable value and that's that. I won't control the fan speed from the PC. To turn on or off the Pico PSU, I want to make a USB dongle that enables a relay, which then pulls the enable line on the connector to ground and turns it on that way. That way, the Pico PSU only turns on when the Framework board is turned on. All will be mounted to this 3mm thick steel sheet that is roughly the same size as a micro ATX motherboard. I kinda underestimated how much 3mm are, so this thing is pretty hefty. But it also was rather expensive and I'll be going forward with it. For the case, I will use the one that's currently housing the old server. And there also will be a lot of 3D printed stuff that I haven't made yet. But now I guess that's everything. So let's get to testing before I screw it together. In order to test it, I set it up on my bench first. Here I'm just plugging in all the cables and getting everything ready for the first boot. After that, I gave it another quick look and turned it on. Now that it looked like it's booting, I needed to take out my laptop to check it out. Following this, I recorded 30 minutes of me messing about on my laptop. There's also a screen recording, but I can't align it to the video properly, so let's just cut to that. I was just booting Pop OS because I already had a thumb drive with it laying around, because I wanted to check if the SATA controller would be detected properly. In retrospect, I should have booted Android, because not doing so will bite me later in the video. After waiting for it to boot, I went into the disk manager to check if the speed of the SSD is what it should be. The battery warning you're seeing, by the way, is from the wireless mouse I used to control the PC because PyKVM wasn't working right yet. The speed test result was as expected, and so I concluded my testing and assumed everything was fine. It wasn't, but that's not the SSD's fault. After that, I also tried to fix the input issues I was having in PyKVM, but to no avail. I later replaced the Y cable and it suddenly worked fine. So now that I tested everything I wanted to test, I shut it back down so I could prepare for assembling it. To mount it, I taped the motherboard and the SATA control to the steel plate where I wanted them to go. Then I took a marker to mark the points the mounting hole should be positioned at. After that, I used my Dremel drill press to drill the holes I marked, or at least I tried. Turns out 3mm are a lot, and a Dremel is not a drill press. Probably should have seen this coming. So I gave up and quickly designed a motherboard-sized plate I could 3D print. Since Micro ATX is a bit bigger than the print bed, I had to split it into two parts and join them with dog bone joints. So now that I rearranged the camera to give you a better view of what I'm actually doing, I could mount the two PCBs onto the plate. Because I wanted the two boards to sit flat, I had to use a riser clip. Here I'm desoldering the power connector on it because it was in the way, and also because the M2 to PCIe adapter already had one. Now that this was out of the way, I could continue mounting the boards. The next thing on the agenda was the power supply adapter. I made a bracket to house the two PSUs where normally the PC power supply would go. For now, I just had to put them in and tie up the cables for later. The other thing that bracket would hold would be the PyKVM. For this I made a little shelf on top of the power supplies where I could mount the Pi and the HDMI adapter for it. This then screwed into the top of the bracket. The next thing was the relay USB dongle that turned on the Pico PSU. I already had soldered the parts together off camera and put them into a little plastic housing. Now I just had to connect it all up to the PSU and find a place to put it on the board, together with the USB dongle. I then mounted an active cooler onto the Raspberry Pi, because I wasn't sure if it would get enough airflow on that location. Mounting brackets for the SSD, the Ethernet plugs on the back, and the Pico PSU. The I/O shield has a big hole on the top, because I wasn't sure if it would collide with the motherboard. Now I connected it all together to check if everything was still working before putting it into a case. Since that was successful, I shut down my existing server and started to take out the parts I no longer needed. After that, I could put in the new parts. First was the power supply bracket. Following that, I installed a motherboard and the I/O shield, or at least I tried to. In the end, I had to use a drill to enlarge the mounting holes to make it fit properly. With that, I finally could install the motherboard. I gave up on the I/O shield for now. After that, I installed the PCIe slot bracket for the PiKVM power supply, the SSD in its adapter, and the mounting bracket for the Pico PSU. I then plugged all the cables into the drives and closed up the back panel for the first time. Now it was time to plug in all the USB cables into the motherboard and connect the Pico PSU relay. I also had to temporarily unscrew the PiKVM holder to plug in all the required cables there. In between my lousy attempts at cable management, I also plugged in all the fan cables. And after that, I could button it up and it was ready for the first boot. Or so I thought. So now that it's ready to be tested, let me put it back into its original place and turn it on. Initially, I planned to have a section where I turn it on and show how well it works here. When I first turned it on, the PiKVM worked flawlessly and I could view everything no problem. But then Android had a different idea. Everything seemed to work except networking. I assumed this was just a bad config somewhere and I started my attempts at finding and fixing it. I recorded about 45 minutes of footage of me doing so, after which my camera ran out of battery. So I decided it would be smart to take a break, do some research and recharge my camera. And that's what I did. Turns out that I'm not the only one that has problems with the chipset used in my Ethernet dongle on Android. There are a couple of old forum posts going back years. The only solution, which also was recommended by the helpdesk by the way, was a patch from the Chinese language section in their forum. It was basically just a zip file with stuff to overwrite your original files on the boot drive with. I don't think I have to say how sketchy this is. Not only that, but it was also pretty janky because it had to be redone after every update. But because I had no other option and just wanted it to work at this point, I installed the patch and it did what it promised. So I started to use it for a bit and everything was fine. Even began to edit this video off of it. But then I checked the power consumption of it in Home Assistant and I was shocked. The power consumption was down maybe 5 or 10 watts. That's not nothing, but in my opinion it wasn't really worth the extra jankiness it brought with it. So I undid everything and now the server is back to where it started. But while looking at the power consumption, I noticed something else. While the server was turned off and on my bench, there still was about 40 watts of draw on the meter. That's because the UPS was still active and that was just its standby power. I knew that it was overspec'd for the server, but I already had it sit around unused when I set it up and I thought nothing of it. So in the end I did what I should have done at the start and replaced the UPS with a smaller one. That way I could get the power usage for the whole thing down by about 20 watts to about 55 to 60. So that's that. I basically spent a lot of time and money into this lesson, but at least it was fun. But the important question now is, should you do this? If you already have a framework motherboard laying around, absolutely. You probably could do something like this with a different laptop board, but your mileage may vary. If you first have to buy one, it's probably not a good idea. The power saving you're gonna achieve is also not that big if you're planning on replacing a fairly modern server with it. The big two issues I had were the jankiness of the solution and the driver support. The driver thing could have been easily circumvented by testing it beforehand. One could have looked for a different USB dongle or other software to use with it. And just in case someone from LimeTech is watching this, what the fuck are you guys doing? The jankiness is a bit more complicated. With more planning, some of it could have been eliminated. But at the end of the day, you're still using the motherboard for something that wasn't designed for. Ideally, someone could make a custom PCB to utilize all the connectors on the mainboard to free up some Type-C ports. Framework regularly shows interest in using old boards as small form factor computers, so this might be something they could do themselves and sell it as an official add-on. I'd buy it. But that's it from me for now. I hope you liked the video. Like and subscribe and all that stuff. I don't really care, and see you later.